Okay, this is continuing with 2.72 variable inequalities, but now we're going to graph an absolute value inequality. So let's say we have y is greater than the absolute value of 2x plus 1, close your absolute value, minus 3. So to graph this, we're going to first graph the boundary line, like we did in the previous video, and we'll first find the vertex. So this is in the form of mx plus b plus c. So we're going to first find the vertex by using our formula of negative b over m, comma, c. Okay, so we have our vertex. We know b is 1, so we have a negative 1 over our m is 2, comma, our c is a negative 3. So we're going to go ahead and graph that. We'll draw in our axes. And we'll first plot the vertex, and then we can use our slope to find other points. Okay, so we're going to plot our vertex of negative 1/2, negative 3. So we go over to negative 1/2. So if this is a negative 1, we go halfway over, negative 1/2, and negative 3. 1, 2, 3. So we'll be about right here, which is negative 1/2, negative 3. And that's our vertex. So now to find other points, we're going to use our slope, which is 2. So you can rise 2, 1, 2, and run 1. And we'll have another point right here. And that point is a half unit after negative 1. So it's going to be negative 1.5, comma, negative 1. And we need to go in the opposite direction as well. So we'll rise 2, 1, 2, and we'll run 1. So now we'll be right here, which is going to be the point 1/2, comma, negative 1. Okay, so before we finish this, we need to look at if it's going to be including or not including the boundary line. Since it's just greater than and not greater than or equal to, that means it is not including the boundary line, and we're going to draw in a dashed line, meaning it's not including it. And then we're going to shade everywhere above because it says y is greater than. So I'm going to shade everywhere above my boundary line.